One characteristic of the marine west coast climate is it's going to be a little bit more wet than the Mediterranean climate. Key characteristic of a marine west coast climate region is you're going to find very mild winters but cool summers. This makes sense. The name marine is going to indicate that this is going to be a climate region that's very close to a water body. And so thus, once again, we're going to have our highs not as high and our lows not as low as we would find along the same latitude further inland in a continental climate area. Further, these are going to be areas that are poleward of a Mediterranean climate region. In other words, in the northern hemisphere, these are going to be found north of the Mediterranean climate region. As the name also implies, marine west coast, you're going to find these on the west coast of continents as well. Further, we're going to see, because this is going to be a little bit more closer to the poles, a little bit further north in the case of the northern hemisphere, MP, or maritime polar air masses, do a good job in dominating and bringing in a lot of that precipitation, which helps to moderate the temperature. Where do we find this type of climate region? We're going to find it in Western Europe. So this is when we think about Ireland, when we think about England and Wales and Scotland, parts of northern France, parts of northern and central Europe. This area is going to be affected by a marine west coast climate region. Further, the Pacific Northwest, so of course the places like Seattle, Portland, and Vancouver would be examples of places that have a marine west coast climate region. But the Appalachians, wait a minute, the Appalachians are middle of East Coast USA. Well, one of the things is the western slopes of the Appalachians actually kind of have a very similar characteristic where, because of orographic lifting and because of that warm, moist air coming from the Gulf, because of the general wind direction and orographic, can actually get very similar characteristics in terms of temperature and precipitation as you would find in a marine west coast area. Now let's compare and contrast a Mediterranean climograph with a marine west coast climograph. First off, you're going to see in both instances a drier summer, and so that's due to the subtropical high pressure in both instances helping to come over this area and bring comparatively drier weather. One of the things you will note, however, is if you look on the right-hand side of the marine west coast climate, you're going to see higher precipitation levels throughout much of the year. And so you're going to see more of a mid-latitude cyclonic activity playing a key role, but you're also going to see orographic helping to provide a lot of that precipitation as a maritime polar air mass comes in contact with the coast. Further, when we look at temperature, if you look at the Mediterranean, it's a little bit more horizontal. It doesn't have as much variability as the marine west coast, which has a little bit more up and down. We can see in January it gets below 40 degrees Fahrenheit, but then gets as high as nearly 60 or over 60 degrees Fahrenheit. So it's much more drastic. And that's key to understanding that is the fact that the Mediterranean climate is closer to the equator. And once again, as we increase in latitude, our temperature variability increases because we have greater changing sun angles, but also greater changing day lengths. Now we see poleward, or to the north in the case of the United States, of the Mediterranean climate region, the marine west coast climate. Name this marine west coast city. Here we have a temperate rainforest, and so this is obviously not a tropical rainforest. This is going to be found in much cooler areas, like we would find here in the Pacific Northwest. And so here's an example of a temperate rainforest. Key to understanding what causes, allows this dense vegetation is orographic precipitation combined with that maritime polar air mass that often influences this area. So here we have an area that's latitudinally much further away than the tropical rainforest, however, still provides a dense understory of vegetation. Here we're going to see many coniferous plants, but also a good amount of broadleaf deciduous trees and a ton of mosses, which we can see in this image here. One of the things is we're going to look on the next image of kind of illustrating that this area, to see this much dense vegetation, requires a ton of precipitation. Remember what Kermit said. Here we have two different trees, and so the California North Coast, there north of San Francisco, actually has this key characteristic climate region that allows such massive tree formation that you can actually drive through them, as this postcard here illustrates to the left. And you can actually drive through a couple of these out there. If we look on the right-hand side, this is what we call a red maple. Red maple can pretty much live anywhere in the eastern coast, eastern part of the United States. Pretty much, even from Iowa to Nebraska, all the way over to New York, and pretty much red maple can live anywhere. However, if we think about the tree on the left, key to understanding it is it's very specific as far as where we can find it. And that's going to be along the California coast, where we're going to have orographic precipitation providing a constant drizzle, providing a constant precipitation drip, which allows these coastal redwoods to grow to be so massive in terms of their size. Here we have a little seedling. It's a sequoia seedling that grows up to be a little guy that during its life becomes massive. So some of the tallest trees we have on Earth can be found in this climate region. Did you know that the world's tallest tree might be actually here in the United States in this climate region?